So we start with the recap, where in last class we have studied about the moments. The moment simply refers to the phenomena of or the effect of force that's called the turning effect. That's called the turning effect. And we studied in our last class also that suppose if we have any object and if this is at the center of mass, if we apply the force at this point, naturally this object will get displaced to a new position, which can be said like this. So if we take any reference particle point, let us say A, it will straightway move and its new position will be A dash. Likewise, okay, but suppose if it so happened that for the same object which has got center of mass here, but we apply force at certain distance, then the object, instead of moving linearly like this, the object little bit takes a shape like this. It will be displaced in this way. So if we take any again reference point as A, then because of the application of force here, we find out that this point A experiences an angular displacement, which is not in a straight line. Here, the displacement is a straight, but here the displacement is curved. This type of effect is called turning effect. Practically, we say that turning effect is taken in case of like moment is equal to, we say that force into the perpendicular distance from fixed point, from fixed point. As far as our syllabus is concerned, we say that sometimes the fixed point is treated as pivot, sometimes it is treated as pivot side, or sometimes the same will be treated or will be referred to as fulcrum. The meaning is same. It's like this. Suppose if we say that we do have a device which we know that's a seesaw, which is balanced at this point. So this is treated as a fulcrum. Absolutely, this can be treated as the fulcrum. And we know that there is the minute hand or a second hand in a wall clock. In a wall clock, those points where the point where these hands they are joined, that is treated as pivot. That's treated as pivot. Sometimes to be pronounced as pivot also. In simple cases, whatever the hinges which are connected to the door for its angular displacement, these hinges, they work like a pivot. So this is what about we can say basic of the moment. Now we know moment is equal to force into perpendicular distance. So suppose if I say that this is an arm which is pivoted here, and we start applying a force of, let us say, 1 Newton here, then 1 Newton here, and then 1 Newton here as an example. This is different location. So the moment produced here, which we call it as M3, will be greater than M2, will be greater than M1. So I can simply write down the equation for moments. Now here, moment will be like this. Here, the moment will be like this. Here, the moment will be like this. Back to the square. What is moment? Turning effect. On which factor it depends? First is force. Second one, the perpendicular distance from this pivot point or a fulcrum part. calculation, it becomes simple for that. Then under this topic of moment, we have to go on for two essential cases. The very first essential case, we call it as couple or torque. We will discuss that separately. And the second one, which is more important, I'll go for the next page, that is actually the principle of moments. That is the principle of moments. So let's get back in order to begin with couple or a torque. We know that a couple means any two things which are in support with each other. Torque is an alternate name given for such action. So where exactly it is used? We can say that suppose if there is a handle, suppose if this is the handle which is pivoted at its center point, and then two equal and opposite forces, they are acting at the same distance on either side of the fulcrum. So I can simply say that this is F, this one is also F. So what will be the moment due to this F? I can simply say that F into D. What will be the moment due to this F? I know that this is also FD. And the surprising thing here is that whatever is the direction of moment for this F supports this F, and whatever is the direction of the moment here will support the another F. So basically these two forces which we find out that they are opposite to each other, they're actually helping each other. How come? They are opposite but on the opposite sides, so they are together. Result of that, the net couple, it will be like this, which we call it as a torque, that is represented by the symbol tau. So this type of symbol is to be treated or is called as tau. Some book, some professor, they may pronounce it as tau. Both the pronunciations are okay. Now this simply becomes equal to 2 times FD, and that's the simple formula. But is it needed that every time these two forces should be equal? Is it a mandatory course that I can define it like two equal and opposite forces, two equal and opposite forces are acting at same distance from the fulcrum? This is what is happening in this diagram, but it is not mandatory, it is not needed, it's not necessary. It may happen that we can have a situation in this case like this also, that here there is a fulcrum, here there is a pivot, one force is acting at this point, another force is acting at this point. I'll call it as F2. This is F1. This is F2. And here there is a force which is F3. It may happen that F3 is at a distance of, let us say, D3. Their distances may be D2. Maybe here let's call it as D1. And if it so happen like F1 D1 plus F2 D2, F1 D1 plus F2 D2 is equal to 2 times F3, sorry, it's not 2 times, is equal to F3 D3. then even in that case, we can easily get about this torque or a couple. How? Whatever together they are doing, whatever the moment that these two together they are creating, which is exactly equal to this moment. So I can simply say that in this case, the torque tau will be equals to F1 d1 plus F2 d2, which is absolutely equal to plus F3 d3. Now we need to take care that how to go ahead for the further calculations. Let's see a special case. First of all, suppose if it so happened, suppose for the same situation, if I say that F1 d1 plus F2 d2 is somehow is not equal to F3 d3, we directly say that there is no couple, no torque is acting on it. Reason, if I compare the two cases immediately here, I can find out that together these two, whatever is the moment that these two are creating, exactly equal moment this is also creating. So what happens under this case? The clockwise turn, because of F1 and F2 matches with the anti-clockwise turn because of F3. So this is torque due to F1 and F2, whereas this is torque due to F3. They are matching. The way in which these two are pushing onto this F3, F3 is also pushing back to F1 and F2. Perfectly balanced case. So everything is balanced. But when you come on to this part, the combination, the force with which this one creates a moment is different than the moment created by F3. So there is an imbalance happening. Result of that, they are not couple. They are absolutely not couple. It will be like an imbalance case. It will be like an imbalance where the object will not be under controlled motion. For example, let us see. For example, just let us see 1 minute. Huh? Just give me a minute. What we can do? A simple example for application of a couple. Steering wheel of a car, where we know our right hand applies the force inward, left hand applies the force outward, then we get this turning effect. Same is there about the handle of a bicycle, handle of a bike, everything. We can apply this concept of couple. In short, to get a balanced action, to get a real balanced action which results in a turning effect, we must have a condition that clockwise moment must be equal to the anti-clockwise moment. Now in some book you will find out the just 1 minute, just 1 minute. I'm really sorry. Both are anti-clockwise. Both are anti-clockwise. I'm really sorry for this. Anti-clockwise moment due to first should be equal to anti-clockwise moment onto the second one. So I'll just erase this on. I can simply write down an equation like clockwise effect or anti-clockwise effect due to 1 should be equal to clockwise or anti-clockwise due to 2. Now they are supporting with each other. They are absolutely supporting onto each other. If they are not balanced, if they are not equal to, we will never get the couple of moments. And that's what exactly happens when you open up the cap of a water bottle. Have you ever tried to open up the cap of water bottle, assuming that if this is the water bottle and here the cap is fixed? Now you have to open this. So you hold the bottle in your hand, your thumb takes a motion like this, and your other all four fingers takes a motion like this. It's right. Just imagine whether you open, whether you close, it is basically a couple. So whatever the moment that thumb is creating, same moment the other four fingers must create. Otherwise, what will happen is that the bottle cap will get opened, but it will fly off in one particular direction. And that can be easily observed that when you try to open up the bottle cap with a finger, what is alternate method? Suppose if I say that I'll erase this afterwards just to avoid confusion. Suppose if we say that this is the bottle neck on which this cap is fixed and you want to open this cap. So what you do, you can have the whole hand and you give a jerk on the cap on this direction. Single side. It's not couple. It's just a moment. Because of that, the cap, it takes a turn like this. The cap comes out of thread and ultimately the caps goes up. Reason? It is imbalanced. You are applying only one force, very second force. It's not there. But when we say that we are using the balanced forces, we always get a couple. Any difficulty? Principle of moment deals with the condition of equilibrium. Now we know equilibrium is a synonym for something called balanced forces. Balanced forces. Or it is a synonym something called no net force. That's the meaning of equilibrium. So suppose if I say that we have a body on which from this side 5 newtons are acting, a force of 5 newton is acting, and this side exactly opposite to that, another 5 newton force is acting. This is under equilibrium. Now the body is not moving. What is the net force on this body? Zero. Are the forces balanced? Yes, the forces are
Yes,
balanced. It's an equilibrium. But suddenly, to this situation, if someone says that we are applying a force of, let us say, 0.1 Newton, now it is in non-equilibrium, in equilibrium state. There is a net force acting on this. This 5 Newton balanced by this 5 Newton, but there is no one to balance this. So there is a net force acting on this body, and the body is said to be in non-equilibrium state. Exactly same way we talk about principle of moments. So what principle of moments simply says that it just goes like this, like under the equilibrium, under the equilibrium condition, under the equilibrium condition, anti-clockwise moments, anti-clockwise moments are balanced by clockwise moment, are balanced by the clockwise moments. This is the simple condition. Then what is the net moment? Zero. And that's what is equilibrium. So if it so happened that we have an object with fulcrum at its center, and it is such that there are two forces acting on this side, F1 at a distance of D1 and F2 which is at a distance of D2, and here there is F3 which is at a distance of D3, and let us say as an example F4 which is at a distance of D4, and the values are such that F1 D1 plus F2 D2 is equal to F3 D3 plus F4 D4. Then we say that this is under equilibrium. This is under equilibrium. So what equilibrium, or what is the condition, what's the principle of movement says that under equilibrium condition this must be satisfied. Now if you look, F1 D1 plus F2 D2, their moment is anti-clockwise. Their moment produced because of F1 D1 anti-clockwise, F2 D2 anti-clockwise. So they support each other to give a resultant anti-clockwise moment, which we call as anti-clockwise moment. These moments, they are treated as positive. Be cautious, remember there. Anti-clockwise moments, they are always considered as positive. We will explain it afterwards. Clockwise moments which are produced by F3 and F4. Now these moments which are actually clockwise moment, they experiences a head-on collision, a strict opposition from this moment. Now if they are equal, they balance, net force is zero. If they are not equal, anyone who is dominating will give the turning effect. So these types of moments which we now call as clockwise moments. Clockwise moments which are taken as negative. This is more important. How? So here comes the analogy with which basically we measure an angle by means of a protractor. We measure the angle by means of protractor, where this is treated as 0. Then angle 10 degrees, we immediately draw like this. This is 10 degrees. Minus 10 degree, we draw like this. This is minus 10 degree. So this side positive, this side negative, and that's what we have done here. See, clockwise negative, clockwise negative, anti-clockwise positive, anti-clockwise positive, and therefore we can directly say that whatever is this angle which is at 90 degree is 90 degree but plus. And what about here? We can say that it is minus of 90 degrees because we are going in a clockwise direction. This is special one which depends on which side we are measuring. If we measure it from this side, it is plus 180. But if we measure from this side, it becomes minus 180. That's what we fetched here. Can you take a screenshot of this?
Yes.
Yeah. Okay. Anything that you want me to repeat because time left is very less? Let the meeting end. Rejoin fast.